In this video, I'd like to talk about the math question of the day for Sunday, May 14th, 2023. And for this problem, we have an integral involving a square root, and integrals like this will typically be seen in a Calculus 2 class when you cover the various integration techniques. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And for an integral like this, it's a bit complicated, but we can try some substitutions. You might start by just making a substitution for what's inside the square root, but you'll realize that that substitution will not be too productive. But we could try substituting for this entire square root. We can say that u is the square root of x minus 4. But when we try to rewrite this as du in terms of dx, it will be fairly messy because we could rewrite this as x minus 4 to the 1/2 power. We'd have to use the power rule and we'd end up with a fairly complicated expression there. However, what we can do sometimes is rewrite this substitution in terms of x. We can square each side of this so that we get u squared is x minus 4, then add 4 to the other side so that u squared plus 4 is x. And then from here, rewrite this in terms of dx and du. So we can use the power rule on the left-hand side. We get 2u du, and this is just equal to dx. And from here, now we can make our substitution since we have a simple expression for dx. And rewriting this, we'll have the integral, and actually we can factor the 7 out to start, of dx over this bottom expression. And dx is 2u du. And in this denominator, we have 2 plus this square root expression, but that's just equal to u. Now we've simplified our integral. We've gotten rid of our square root. And we can just make another substitution. We can say that v is equal to 2 plus u, so that dv and du are equal to each other. And since we have u in the numerator, we'll need to rewrite this in terms of u, or equal to u, so that we can plug in what this expression is equal to in terms of v. So let's subtract 2. We get u is v minus 2. So we can plug that in right here, and this denominator will just be equal to v. So let's continue this. Down here, we have 7 multiplied by this integral. And since we have 2 times u, let's just factor out that 2, so that we have 14. Multiplied by the integral of du, but du is now dv. And we also have u, but u is this v minus 2. And actually, let's write that first. We have v minus 2 dv, all divided by 2 plus u, but that's v. And from here, we can actually evaluate this. Let's actually divide v into both of these so that we get 14 multiplied by the integral of v over v minus 2 over v. And we have dv here, which is 14 multiplied by the integral of 1 minus 2 over v dv. And we can evaluate this now. This will just be equal to 14 multiplied by the integral of 1 dv, which will just be v, and the integral of 2 over v, well, the 2 could be factored out, and the integral of 1 over v dv would just be the natural log of v. So we have minus 2 times by the natural log of the absolute value of v, but we started our integral in terms of x. So let's put everything back in terms of x, though we will have to first put it back in terms of u, and then we can substitute back for x. So let's distribute this 14 now. We have 14 multiplied by v, but remember that v is 2 plus u. So So we have 14 multiplied by 2 plus u. Then we have minus 14 times 2, that's 28. The natural log of v, or the absolute value of v, but that's just 2 plus u. So let me make a little bit more space. We have the natural log of the absolute value of 2 plus u. And I should mention we do have our integration constant, so we don't want to forget that. And at this point, we could put everything back in terms of x, since we know that u, if I go up a little bit more, is the square root of x minus 4. So let me rewrite that. We have u is the square root of x minus 4. And we'll just plug that in anywhere we see a u here, so that for our final answer, we would get 14 multiplied by 2 plus the square root of x minus 4 minus 28 multiplied by the natural log of 2 plus u, but that's the square root of x minus 4. Close that absolute value, and we will have our integration constant because this is an indefinite integral. Now, if you do want to check your work, it's a little bit tedious, but there are a couple different ways to do it. One is that you can take this expression and just find its derivative. And if you end up with that original integral, then you know you did it correctly. Though you can also use an online integral calculator to check your work that way as well.